All right, y'all, welcome back. Thank you for being here for CA2 review. This is part 2 on our Unit 2 physics. The first section we're going to look at is unbalanced forces. So remember, an unbalanced force creates an acceleration of objects, and those objects will always accelerate in the direction of the larger force, okay? We have different types of forces. Our first force is an applied force, which is a push or a pull, okay? Then we have a frictional force, which will always act in the opposite direction of the applied force. For example, if we're asked to find the net force, we know that we need to subtract two forces when they run in opposite directions or add them if they occur in the same direction. For example, here we have a box and we have an applied force of 50 newtons to the right. Okay, so our arrow is moving to the right. But we also have a frictional force of 30 newtons in the opposite direction. Applied force and frictional force always work in the opposite directions. So here our arrows are in opposite directions, therefore we need to subtract to find our net force. We always will do our larger number minus our smaller number. 50 minus 30 equals a net force of 20 newtons to the right. It was to the right because that was the direction of our larger force, since 50 to the right is larger than the 30 to the left. Our next section is force equals mass times acceleration. Y'all remember, this equation will be given to you on the test, but the magic triangle will not. So anytime that you have a force, mass, or acceleration problem, you need to write this equation down and then draw your magic triangle, right? So if a force is constant and mass decreases, then the acceleration must increase and vice versa. Let's look at an example of that. For example, if we have a force of 20 newtons, and the way that we got that was multiplying a mass of 5 times an acceleration of 4, right? 5 times 4 gives us our 20, okay? And I said that we're gonna keep that force constant. In the next example, we're gonna keep that constant. And we look and we see now we have a mass of 10 kilograms. So our mass increased. What must happen to our acceleration? It must decrease, right? It went from 4 meters per second squared to 2. The reason that is because if you have a larger object and you use the same force to kick it, for an example, a basketball, and you try to shoot a light basketball, it's going to accelerate much quicker. Its speed will increase much faster than if you tried to, for example, shoot a medicine ball that was much heavier, okay? Moving on to the next section, we have our speed versus velocity versus acceleration. The key here is that speed is just how fast we're going. For example, 5 meters per second is a speed. Velocity is how fast you're going, or your speed plus a direction. For example, 5 meters per second east is a velocity, okay? Acceleration is any change in velocity. So for example, speeding up or slowing down or changing your direction is acceleration. The next section is position versus time graphs, right? Every time we look at a position versus time graph, we want to remember that our 0, okay, our axis is our starting point, okay? An increase on our graph means that we're moving away from the start. Our position is increasing. And a decrease means that we're moving back towards the start. A flat line on a position time graph, well, that means that we have the same position, the same distance over a certain amount of time. So you're staying in the same place, which means that we are stationary or stopped. A straight line, however, means that we're at a constant speed. Okay, so if we have a straight linear line, that means that our position as compared to our time is increasing the same amount throughout the whole time, or we are at a constant speed. Speaking of speed, our speed equation, right? We have speed equals distance divided by time. This is also given to you on your formula sheet. However, our magic triangle is not. So if you need to solve for speed, here's our magic triangle. The last part of physics is Newton's laws. Our first law here is an object that is at rest will stay at rest, and an object in motion will stay in motion unless acted on by an outside force. This was an example that we did in class where we had our graduated cylinder and I had a paper clip on top of the index card, and if you pull the index card out from underneath that paper clip quickly, remember what happened to the paper clip. It stayed in its same spot and then fell down due to the force of gravity. The second law is just force equals mass times acceleration. We've been doing that all year. Our third law is that for every action, there is an equal and opposite reaction. So a great example of that is our pulley. Of course, if M1, okay, so if M1 goes up, then M2 must come down. If M1 goes down, M2 must go up. So if we add weight to M1, we know, well, it must go down, which means M2 must go up. But if we take weight off of M1, it's going to go up, and we know that M2 then will go down. Thank you guys so much for staying with me for part 2 of our CA review. I'll see you on part 3.